In 1.6, we're going to be talking about least common multiples, and we already reviewed in class what the difference between factors and multiples were, so we're going to remember that multiples are numbers that are bigger than a number. They come out of a number when you multiply it, and when we're talking about a least common multiple, it means we're going to be comparing two different numbers, and we're going to be looking for the smallest number that they can both go into evenly. In example 1, we're going to be finding the least common multiple using lists of multiples. So we're going to try to find the LCM, or least common multiple, of 4 and 6. And since we're just going to use lists this time, we're literally just going to stack these up and we're going to start listing multiples. So if we start with the number 4, we're going to figure out what 4 would go into evenly. So 4 always goes into itself at least one time. Then it would go into 8. And if you'll notice, it's kind of like doing what it's multiplied by. So it would be like times 1 would be 4, times 2 would be 8, and you kind of keep on going. Times 3 would be 12, and so on. And you can keep listing that dot, dot, dot means it could keep going. Now, because multiples can literally go on forever, because you could multiply it as many times as you needed to, we don't want to list forever. We want to just start. I'm going to always suggest starting with 3 to 5 multiples at a time. So we've got 3 here. We could do a couple more if we wanted to. And then do your other number and compare, because you're looking for the smallest one they have in common. So if I start down here, 6 would go into 6 once, it would go into 12 twice, and I already found something that they have in common. And since I'm looking for the smallest, or the first number that they have in common, I don't have to list anymore. So the LCM, or least common multiple, of 4 and 6 is 12. That means that's the smallest number that they would both go into evenly. For this on your own, find the least common multiple of the numbers, again making sure that you use lists of multiples. In example 2, we're going to find the LCM, but this time we're going to use prime factorization. And you'll find that this one works better again when their numbers start to get a little bit bigger, because especially with multiples, when you're having to figure out which numbers come out of it and are bigger, you really get into big numbers quickly. So using prime factorization, even on slightly bigger numbers, will make your job a lot easier, especially with a little bit of practice. So we're going to find the LCM of 16 and 20. And again, neither one of those numbers is huge, but if we already have to start counting, skip counting by them, 16, the next number up would be in the 30s already, 32. So we're going to get big pretty fast. So we're going to try this prime factorization method. And so step 1 is going to be to make a factor tree for both 16 and 20. So I have factor trees for 16 and 20 here. And again, you might not have started in the same spot that I did. You could have done 8 times 2 or something else, but you should end up with the same final prime numbers that I have. And same thing for 20. You might have started with something like 10 times 2, but you should still end up in the same spot. And then step 2 here is going to be to write out your prime factorizations. So my prime factorizations, because again, we're practicing writing things in least to greatest order, so they should be starting to look kind of the same. For 16, I have 2 times 2 times 2 times 2. And for 20, I have 2 times 2 times 5. And up until this point, you might notice it's starting to look a lot like what it did when we were doing the greatest common factor to numbers. And at this point, if we'd been looking for the greatest common factor, we would start looking for pairs of numbers, one on each list, and then we would start multiplying those pairs. But here's where you're going to have to know the difference between greatest common factor and least common multiple. Greatest common factor we were looking for had to be smaller than either of the numbers that you were working with. And so that's why we looked for a pair on each list. Multiples have to be at least this big or bigger than your biggest number in order to be the smallest number they could both go into evenly. So we're going to get into bigger numbers. So our step 3 is going to look a little different. So for this step 3, we're going to not be looking for things on one of each list necessarily, but we're going to find wherever the prime factors show up the most number of times. So right now I see that we've got 2's, but on this list 2 only shows up 2 times, and on this list 2 shows up 4 times. And since it shows up the most up here, I'm going to circle all 4 of these 2's, and I'm going to not use the 2's on that list then, because they showed up more times in this list than they did down here. And then I have to keep doing this for any new prime factors. So I do have a 5, and there's only one of them, but I have to use it because it shows up the most number of times down here. So I have to use that one as well. And for the final step in this process, we are going to multiply all those circled prime factors out, and this will be our least common multiple of these two numbers. So because I had 4 2's, I'm going to multiply all 4 of those 2's. And then I also had that circled 5, so I'm going to multiply that one. And again, this is going to be something where you're going to want to group or something because it can get big pretty fast. So I can do 2 times 2 is 4, and I can do 2 times 2 is 4 again, and then multiply by 5, or you can group in any order that makes sense to you, but you're going to want to make sure that you don't miss any of these factors. And 4 times 5, I know here, is going to be 20, and so that would be easier for me to do in my head because then 20 times 4 would be 80. And you can do that way, or you can do 4 times 4 is 16, and then you might have to do side math for 16 times 5. But with multiplication, you're going to get the same answer no matter what order you multiply in. So altogether, after I do that, I find out that I get a product of 80. So the least common multiple of 16 and 20 is 80. And again, what that really means is this is the smallest number that 16 goes into and 20 goes into evenly. When you try these on your own problems out, make sure you remember that you're going to try it using that prime factorization method. And I really encourage you to use those steps that you just wrote down. So you should have 4 steps written down. If you follow them in order and you look at that example I just showed you, you should be able to get the hang of this with a couple of tries. And remember, we'll keep trying it in class together as well.